Hey guys, welcome back to day 9. Today was a bit complicated and harder than normal, so I'll take a bit to explain it. So we get given a input array like this, 1, 2, 3, 4, 5, and that this translates into an expanded array like this. And how it works is that it means we start with 1 U space, which is 0 here, and then 2 blank spaces, which is dots. And then we have 3 U spaces, 3, and then 4. It's these dots, and then 5 U spaces again. So every second number is full stops or blank spaces, and then every other number is a incrementing ID, and the length of each of them will be the length of these. And then once we get that input, we want to translate it and essentially left justify all the content starting from the rightmost element. So in this example, we get the right element and we put it here. Then we get the second most right element and we put it here, and so on until we get all the elements to the left. Looking at the code, we first process the input. So you can see every second element, I have this ID which starts at 0. And then I either add that ID to the nums array the amount of times. So say that 1, 2, 3, 4, 5 example, we'll start with 1, and since this flag will be here, we'd add the ID 0 one time to the array. And then the next time it will go through, this will be false, so we'll go to here and we'll add -1 to the array twice. And then we add 1 to the array 3 times and so on until we get the correct input. And then what I did was essentially a 2-pointer solution. So I keep 1 pointer on the right side and 1 pointer on the left side. And we keep the left pointer on the -1s. And then we keep the right pointer on the numbers at the end. And then we just keep switching them effectively. So if the left pointer is on -1 and the right pointer is not -1, we just switch them around until the end. And there was a little bit of logic wrong with this solution. And I just looked at the printed output and I saw a miss one switch. So one of these while loops should iterate one more time, but I couldn't be bothered fixing it. Next, for part 2, this time instead of moving one number at a time, you can only move a block at a time. So in this case, this 99, you can only move the whole block at once to see if it fits. And then you try and move this whole A at once. So for this side, the start was pretty much the same, except now I keep track of free blocks of memory and used blocks of memory. And then I have this for loop here. So for each used block of memory, what we do is we iterate through the free blocks of memory and we try and insert the used block into the free block if it fits. And then if it does fit here, so we have this, we first have this check to make sure that the free block occurs before the used block. And if it does, we check if the free length is greater than or equal to the used length, which means that the used length will fit inside of it. And if it does, then in the array itself, we perform the operation to switch them around. And then I recalculate the free blocks, because once you move the used blocks, now there might be 2 free blocks touching each other. So essentially I'm recalculating them to merge them again. And then at the end, I just print the answer with the expected variables. Thanks.